If you have done web development, whether you have worked on the front end, back end, or both, you have likely worked with async code. It is much like normal code, but you declare functions and methods as async, and you call async functions and methods with await. But why? Why are we doing this? What does async really mean? On the front end, the reason is rather simple. JavaScript runs in a single-threaded runtime, which means that code cannot be run in parallel. Without async, every web request sent from the page would block execution of other code until it receives a response, resulting in the entire page to freeze. Needless to say, if a web UI freezes for multiple seconds, that's bad user experience. With async functions, requests are sent to a background task scheduler that will then wait for a response. Meanwhile, the JavaScript runtime can execute other code. Once a response has been received, the runtime will continue executing code after the await statement. Also, async await is actually just syntactic sugar in JavaScript. The underlying concept that provides actual asynchronous support are promises. These were really fun to work with before the async syntax. Even more fun were callbacks, which is what older JavaScript APIs used to implement the exact same asynchronous support. So that explains front-end, but what about backend? Servers can run as many threads as they want, making parallel execution possible. Why do we need async on the server? Indeed, threading is the way web servers have worked for a long time. The old way that web servers work is that they listen to incoming new client connections and spawn a new thread for each new connection. Then, that thread receives data from the client, sends a response, and then shuts down. A more optimized variant is with thread pools, which allows reuse of existing, unused threads to avoid the performance cost of creating and destroying threads. The problem with this architecture is that the more simultaneous client requests the server receives, the more threads it needs to spawn. A large amount of threads is going to consume a lot of OS processing time just to manage those threads. Worse yet, the large amount of threads are kind of unnecessary. Each thread spends most of its time waiting to send and receive data with the client, or waiting to send and receive data with the database or some other service. And these are the pain points that async servers are tackling: reducing the amount of threads and reducing the amount of idle time in threads. With async, instead of spawning a new thread for every connection, the connection is handled with an asynchronous task. This task is then pushed to a queue where one thread in a set of worker threads will pick it up and start processing it. The task can then start other asynchronous tasks, which are similarly pushed to the task queue. This improves the utilization of threads. We only have a fixed set of worker threads, the amount depending on the CPU cores of the machine or on manual configuration, and these threads are doing actual computing most of the time. There is an intermediate step before a task is put back to the execution queue. Usually, the asynchronous task will depend on receiving data from a connection before it can continue. The task scheduler will wait for this availability of data before the task is started. This resolves the second problem with threads. Threads will not be idle, waiting to receive data. The reduced amount of threads and idle time of threads is a significant change in web servers. Modern servers with async architecture can handle lots of connections, even with cheaper hardware like Raspberry Pi. But async architecture does not improve performance across the board. It only improves it if your backend service mostly involves sending and receiving data across the network. If your backend involves lots of computing, async is not going to help with that. But most backends are of the former kind, which is why async is the de facto standard now. Another benefit of async code is that it is thread agnostic. You can run the same async code in a task scheduler that is single-threaded, as well as a scheduler that is multi-threaded. Single-threaded schedulers are useful if you are running the program with a CPU that only has one core, or if your program is not thread-safe. In game engines, async code has many use cases due to the time sensitivity of game logic. Waiting for a specific amount of time, waiting for the next frame, or waiting for some other event to happen are common use cases that async fits well. Unity supports the concept of coroutines, which are essentially async code implemented with enumerators. Such a system could be replaced with async code that uses a single-threaded task scheduler. The benefit in this case is that async tasks can modify the state of the game without worrying about thread safety, because the tasks are always run on one thread. A downside of async code that you may recognize quickly is the pollution of your codebase. Async and await everywhere. This is an unfortunate side effect of async, but it's also kind of necessary. Async code is distinct from synchronous code, so it needs to look a bit different. Programming languages can be designed in ways that do not need this async pollution, but that would require significant changes on how the code is compiled and run, so many language implementations are reluctant to do such sweeping changes just to support async. An example where async is built into the language is Golang. All code in Golang is run in what's called Go routines. These are often described as lightweight threads, but they are not really threads. The runtime can run multiple Go routines even when single-threaded, and it does this by switching coroutines when the running Go routine starts waiting for something, whether it's a response from a network, data from a Go channel, or the passage of time. The runtime utilizes multithreading by running multiple Go routines in worker threads in parallel. And that is async, on a high level. Hopefully this video has helped you understand your own async code better. Like and subscribe for more software development stuff. Bye.